Good morning, Irvin. Welcome back. Happy Friday. Hello, John. Welcome back. Joey G. Good morning. Welcome back. Hey, Asim. Morning. Hopefully you're doing okay. Punch some posts or what? Hopefully your hand's okay.
So basically, I threw the ball, and as my hand was coming down,
Oh,
I hit somebody else on
I
the
gotcha.
shoulder.
Yeah, shoulder got you. At that force, I hear you. Hopefully it's okay. Happy Friday. Hi, Faith. Hey, Bellman. Good morning. Hey, Jordan. Happy Friday. Hello, Alan. Welcome back. Happy Friday. Ryan, welcome back. Hi, Jumila. Good morning. Hey, Emma. Happy Friday. Yo, what's going on? Welcome back. Hey, Santino. Happy Friday. What's up, Wendy? Happy Friday. Hi, Nadina. Hey, Tintin. Kristen. Welcome back. Hey, Zen. Welcome. Hi, Mike. Hi, Micaiah. Frank, welcome back. Welcome back, Frank. Missed you yesterday. Hi, Nadal. Welcome, Nadal. And Kai, welcome back. Hey, Phil. Good morning. Welcome. Happy Friday. Leo. Welcome back, Leonardo. Hope you're doing well. Whoa. Can't see that. All right, sorry. All right, one more minute. Let me pop the attendance in and we'll get rolling for today's class. Hey, Alex, welcome back. Quick day crescendo. All right, welcome back. I hope you guys are all doing well, staying safe. Happy Friday. Sun shining, a little snow falls this morning, but now it's turning out to be a pretty decent day out there. So hopefully you take advantage of this. The weather will turn soon, so take advantage of this weather that we have right now and maybe go for a walk a little later. I'm just looking for Kim. Kim, if you're here, just let me know. Throw in the chat or unmute. All right, so let's check out the COVID report for today. Let's see where we're at in Oneida County. Numbers, total active cases of COVID continue to decrease, 2,036. Good news. More resolved cases are forming, and there's still a few more deaths that were added to the total. The death total, 353. Hospitals, total hospitalization, the number decreased. I think it was 120 yesterday. ICU, I think it went up by 1. So intensive care unit, there's one more person in there, more stress on the hospital workers. whether it's janitorial staff, food workers, nurses, doctors, receptionists, whatever it may be. When you have a big influx of people coming on in, probably not having more, from what I understand, when I read the OD, is they're not adding more nurses, they're adding more people going to the hospital, but the job is just going to be stretched out. So not everybody's getting the same amount of care that they probably deserve. But anyways, big stress on them. Thank whoever works at the hospital. If they're at home with you, thank them. Okay. Daily COVID cases. We left off on the 3rd. There's 83 cases. The 2nd, 54. The 1st, 51. So for the most part, this last week looked pretty solid. Not bad for last week, but then a little bit of a hiccup. So that number right there, who knows what's going to determine the next week. I'll take a week like this, or like the last week. You can see that the last few weeks are still somewhat decreasing until this point. I think that was the second highest value right there. So it's kind of crazy. Like on the 14th, we had 313 cases. And then we had like 51 a couple weeks later. That's pretty cool. So I thought maybe that this would continue. These people would continue to spread it, but something's going on where maybe they're smart individuals and want to contaminate anybody else. When you have that many people contaminated, I wouldn't have expected this to decrease this quickly. Hopefully it continues at that rate, decreasing. Starting to get a little normalcy. On the 22nd, teachers are returning back to school at Proctor, so I will change my backdrop again. No big deal. I'll have the whiteboard behind me. I'll probably do some demos, at least in school. Some experiments that may be relatable, at least, just so you can actually see them. Probably sick of me drawing on the page with a Zoom screen and on my drawings. So maybe I'll do some live ones in front of you instead. All right, so there's a COVID report. Reminder, if you do go party at a Super Bowl party, if you meet with some people, some friends, reminder that COVID is definitely still out there and still has the ability to do some damage. Protect yourself, protect your loved ones. Go out this weekend. Please wear masks, social distance, and obviously wash your hands. People always say sanitize, sanitize, sanitize. Wash your hands is better. Wash your hands. All right. Let's see where we're at today for class. All right. Today's class, here we go. Happy Friday. The quote of the week comes from Colin Powell. There's no secret to success. It's a result of preparation, hard work, and learning from your failures. Love that quote. If you're willing to put the work in, learn from mistakes and prepare, you can do anything. Quick little snapshot of my life. I was the youngest of 4. Mom and dad were together. Mom and dad lived a pretty good life when I was a young toddler, younger kid. But then when I got to high school, money was not coming in too much. So I saw mom, dad struggle financially. And I said, hey, I don't want that life. I don't want to struggle for cold winter nights. I want to have a family. I want to be able to put the heat on. I want there to be food in the fridge. Maybe you're going through that now with your family. Maybe not. But when I saw that growing up, I'm like, that hit me hard. And I said, hey, got to do something for me. So I set myself some goals going through high school. Set myself some goals for college. Made it happen. Went through college, got my bachelor's, got my master's. And then opportunities will fall into your lap. So if you're pushing yourself, you push yourself talked about this before, next 6 years or so, you will pave a pretty good future for yourself. What's going to happen? Some people are going to college and they're going to say, hey, not for me. They may say, see you later in the first couple of weeks. Why? Because you're not going to be forced to go to college. Maybe mom and dad are forcing you to go to school when you're a little bit younger. But when you go to college, it has to come from within you. If you're willing to push yourself, put the hard work in, learn from mistakes, you'll have a good life. Mold the life you want. Start right here. The daily agenda for Friday, February 5th, 2021. Today's a day 2. It's going to be continuing on of Unit 6, which is Properties of Solutions. We're going through topic number 3, molarity. But before I get to molarity, I'm going to give you some time to complete the exit pass. I'm going to call it the warm-up for today on topic 2B, solubility curves. So the warm-up today, I noticed a lot of you guys didn't finish it. I'm going to give you 15 minutes to go through that exit pass, to complete it, to turn it in. It's due by tomorrow. After we're done with that, there's guided notes. We're going to go through a really small little portion of guided notes and 2 examples. We'll watch a flick, and then hopefully we'll get through an example or 2 on the examples from the doc, from the forms. This assignment, I'm going to extend it to next week. It is not due this week. You're not going to see enough examples on molarity for me to say, hey, I feel confident for you to do these. So I'm going to extend this to next week. We'll analyze more examples. We'll move on forward from this topic too. So your reference table is there. A flick is there. Please find the exit pass. If you already did it, you have like 15 minutes to hang out for a while. But the exit pass is right there. Exit pass. Unit 6, topic 2B. Yeah, a handful of you already did it. Perfect. So those 10 of you did it. You're good to go for till 12:05. If you didn't finish it, then you please take the time, 15 minutes I'm giving you, to complete this here in class. I'm going to put you in breakout rooms. If you have any questions, feel free to ask for individual help. I'm putting you in breakout rooms by yourself. In the event that you have questions, you can ask one-on-one questions with myself. Santino asks who they want for the Super Bowl. I think the Super Bowl is going to be a pretty good one. You have some pretty good quarterbacks. I guess they're all right. No Daniel Jones, but they're all right. Just joking. I don't know. I don't know who I want. You? I just want a good game. I have a feeling the Bucs are going to win, though. I'm going to say that Brady experience is going to pull over, but. All right, so I'm going to put you in breakout rooms. Please join the breakout room. If you're done, again, I'll see you at 12:05. Please work on this now till 12:05. Please join the room. If you have questions, ask for help. Okay, hopefully a chance to go through those questions. I'll wait like 30 more seconds for everybody to get back into this session from the breakout room. Okay, is there any questions that anybody wants to see before we move on from this? I'll do one question, whatever the most asked question is, I will do. If there's nothing you want to see, then we'll move on forward and just keep rolling through class. Please put in the chat the question you want to see, if there's anything you want to see for review. Does anybody want to see any questions? All right, thanks. I have a ton of people for some reason, like a lot of inputs for question number 3. Just kidding. Only one person asked one question, question number 3. So this is the question we'll do. That was the most popular question you want to see. After being thoroughly stirred at 10 degrees Celsius, which mixture is heterogeneous? A heterogeneous mixture. So a heterogeneous mixture is going to have to be something that's going to be supersaturated. Supersaturated. Why supersaturated? Because particles or precipitates are going to form. Are going to form at the bottom of a beaker or solution. So we're looking for something that's supersaturated. Constant thing here. We have 100 grams of water. So that's cool. No conversions necessary for that. So we have water is 100 grams. Excuse me. Check out my 100 grams. They both correlate. They're both the same. So that matches my check mark. They're all the same dilution. Samples are 25 grams in each of the situations. So I'm going to mark 25 Gs, 25 grams in each of these. That's the same. 25 grams. Looks like it's around there. And the last thing is different compounds here. So different substances. So I'm going to clear this out so I can zoom in on 25. All right, so 25 grams looks like around there. And we said water is already the same. Let's just check it out. We have KCl. So find and locate KCl. Do that in orange. KCl. KCl. Oh, 10 degrees Celsius. I forgot 10 degrees Celsius in the text. So it says 10 degrees Celsius there. So I'll mark that. So that's my reference point. So again, I'll put the heart or star as a reference point. That point of intersection is our reference point. Reference point. All right, now we can go through and analyze this. So find KCl. KCl. There's KCl. It's orange. I'm going to follow it over here. All right, KCl, that reference point's below the line. So that looks like it's going to be probably an unsaturated solution. The point is below, it's under. Unsaturated. That would be a homogeneous mixture. Next point, find KNO3. Still 25 grams. Find KNO3. KNO3, not on this picture. KNO3 happens to be this curve coming on down. This green one. So that reference point looks like it's just above. That reference point, I'm going to say, is going to be supersaturated. Let's go through the rest of them just to make sure. Find NaCl. NaCl is the red one. Reference point again. Reference point. That reference point's below the line, so that'd be unsaturated. So unsaturated. And NaNO3. So find NaNO3, and we'll mark it up with blue. It's pretty high. NaNO3. So all the way up there. That reference point is under the curve. That would be unsaturated as well. So in this situation, looks like choice B is going to be supersaturated. B is supersaturated. Homogeneous means no, you're not going to see anything. You're going to see just a solution, and you're not going to see any solid particles. If it was heterogeneous, heterogeneous means you will see. Heterogeneous means you'll see a difference in particles. You'll see solids on the bottom, where solids forming, or precipitates, and you'll have a liquid as well. So the only one that's going to be a heterogeneous mixture is going to be a supersaturated solution. The only ones that are going to be a homogeneous mixture are going to be unsaturated and even saturated. If no particles are formed, which there shouldn't be, saturated should be homogeneous as well. Kyle talk about that. It's going to take some time for me to do for that, but yes, if I recall. Irvin. Yeah, it's fine, Irvin. That's going on out. It's fine. All right, so there's question number 3. Hopefully got the right answer on that one. All right, let's go back to the class. Let's see what's going on for today's class. We are moving on forward. We're going through some notes on molarity. So molarity, please open up your guided notes. You guys are pretty good. You guys know exactly where to find it, so I don't have to show you where to find it. But meanwhile, once you're popping this open, unit number 6 is talking about solutions, properties of solutions. Within this unit, we talked about some key terms like solutions or homogeneous mixtures. We talked about alloys as solid solutions. We talked about water solutions being aqueous, AQ, like a homogeneous mixture mixed with water. We talked about breaking up NaCl with water. How does it dissolve? How do ionic compounds dissolve in water? Breaks them apart, the charges apart. We talked about solutions are homogeneous, they're clear or transparent. They can have color, they do not settle upon standing, and they pass through a filter. We talked about a couple terms, more S terms, soluble or solubility, solvent, solute, something soluble versus something insoluble. We spent a couple classes talking about this chart versus soluble versus insoluble. We talked about factors that affect solubility, more S terms, unsaturated, saturated, supersaturated. We talked about dilute and concentrated. We talked about solubility curve, and we analyzed the solubility curve a lot. Yes, we analyzed a lot of examples. You have the exapass to complete by tomorrow. All right, moving on forward, we're on molarity. I'm going to start fresh with a new page. Topic number 3, molarity. As you can see, there's not a lot of notes actually put in here. And there's 2 examples we're going to go through, but it's going to take some time to get through at least example number 2. So let's try this out. So hopefully you're ready. Hopefully you know where we're at. We are at the best class of the day. The sun's out. All right. Molarity. Molarity refers to basically this chart, basically this y-axis. Check out the y-axis. Solute per 100 grams of water. Solubility, grams of solute per 100 grams of water. This actually is molarity. So it's going to be solute per a mass of water or a volume of water. Molarity is going to be concentration. Again, I'm going to color code and I will bold it just so it pops out to you. So concentration of solutions Concentration of solutions and the number of moles of solute. Solute's what you add. Solute in a given volume of solution. Given volume of solution. All right, concentration of solution is the number of moles of solute in a given volume of solution. So basically, if we had a beaker of salt water, the salt water is going to have, the water is going to have a given volume. And if we want to know how many salt particles were in there, the concentration or the number of moles can help determine how much are going to be within there. So concentration is basically how diluted or how concentrated or how many particles are going to be within that given volume. The molarity, capital M represents molarity, lowercase m represents mass, capital M represents molarity of a solution is the number of moles of solute, in 1 liter of water, or in 1 liter of solution, I'll say, in 1 liter of solution. So molarity of a solution is the number of moles of solute in 1 liter of solution. So yeah, that is kind of repetitive, very repetitive to the first bullet. Molarity, concentration, molarity, concentration, same thing. Molarity, concentration, number of moles of solute, per a unit of volume. Unit of volume, yes. I know you guys can come up with a formula from this. The formula is going to be molarity equals moles of solute divided by liters of solutions. So what I'm going to do to put the formula, I'm going to press spacebar like 20 times, maybe 30 times, don't know. The formula is going to be moles of solute over liters of solution. That's going to give you molarity. So I put moles of solute, enter, molarity equals dash divided by liters of solution. Nice formula for you. Liters of solution. Just gonna fill it in. Another thing I'm gonna do, I'm gonna put some units here that correspond to the right symbols. Molarity unit is going to be a capital M. That capital M represents molar. Moles of solute units are moles or MOL. And liters of solution is going to be the volume for the unit for volume is going to be liters, capital L. Molarity equals moles of solute divided by liters of solution. And that's the formula we're going to be expressing and using for the next 2 examples. See reference table T. So let's check out table T. I'll leave this up here in case you need to copy the formula in there. All right, table T is the last page of the reference table. On the last page of your reference table are the mathematical formulas that we will use throughout the class, a majority of them. So let's just check out that last page, see where we're at for the year, see how many we already went through. So these are the ones that you should be able to understand, know how to use, table T. All right, so I'm gonna highlight this. It's been a while since we really looked at this last page. Density, we went through with unit 2, matter and energy. Density equals mass over volume. We went through moles, number of moles in unit number 5 for part 1, ionic bonding. Number of moles equals given mass over the GFM. Hopefully you remember that. We'll use that again today. Percent error, we did in unit number 2, probably unit number 1 as well. Measured value minus accepted, divided by accepted times 100. Percent error we went through, percent composition we went through, but we'll revisit that within the unit. We went through combined gas laws, unit 2. Pressure, volume, temp equals pressure, volume, temp. We went through heat diffusion, heat of vaporization. And we also went through temperature as well, temperature conversions. So last page, there's not many formulas that you still need to see throughout the year. This is the one we're gonna be going through today. So we will be highlighting, we'll be going over molarity today in class. Molarity represents a concentration. So that we'll go through today. In the near future, in this unit, we'll do parts per million. We'll also do percent composition. I think it's next topic actually. So after this unit, which will be done by Valentine's, now you guys took chemistry. We have a half year chemistry under your belt. Might be the year for Valentine's, since you know about bonding, you know about chemistry a little bit, so maybe this is your year, maybe not. COVID. Moving on forward, there's only one more formula to analyze for the rest of the year. That's pretty good. We're in good shape now. We're in good shape for the content. So molarity formula is right there. Enough of that nonsense about Valentine's Day. Worry about your school. Okay, back to this. All right, molarity. Example number 1. It says, what is the molarity of a solution that contains 4 moles of NaOH of 0.5 liters of solution? So here we go. We have this question. There's 2 examples I'm giving you. This one is going to be the easiest type of question you may see on molarity. Example 2 is going to be the most difficult type of question you'll see on molarity. All right, but how do I approach this question? I approach this question the exact same way I approach any question in chem class. I figure out what the heck I have. I figure out what they're asking me to solve for, and then I find an approach probably on the last page of the reference table. So here we go. What is a molarity? We are looking for molarity. That's an important piece of information. We have 4 moles. Moles is another piece of information. The compound we have is NaOH. Maybe we need that. And we have a volume of solution of 0.5 liters. So another piece of information. Once I have that, I probably would underline this with a pencil, all this stuff. Once I have that, I would suggest writing the given information to the left of maybe a piece of paper or left of the question. So this is a given information. And I'm going to relist it again, just so it's all organized and just so it's all together. This is a technique that is very useful, I think, for this class, and especially if you take physics next year, it'll be useful for that too. So I taught physics for years. Students did really well for me when I was at West Canada. I never taught physics at Proctor. But students did really well for me, and I really just coached them through this process. Figure out what you have, figure out what they're asking you to solve for, find the formula, plug it in. It's really not that bad. If you follow that approach, it's going to make it a lot easier. And physics is a lot of math. It's a lot of breaking up questions and figure out what's given, what's that number even mean, what does moles mean, what does liters mean. And a lot of the formulas are given to you on the reference table. So as long as you're willing to do that, follow those steps, you should be okay. Given information, so we have molarity. I can We're taking some guide notes. So molarity is the first thing I have. Molarity is represented by a big M. And I'm looking for that one. We're looking for molarity. What is a molarity? We're looking for it. Okay. Next up, I have 4 moles. 4 moles represents moles equals 4.0 moles. Abbreviation for moles is MOL. My daughter wants a LOL, not MOL. LOL doll for Valentine's. I said, Valentine's isn't about those types of things. She thinks it is, but she's 5. I have the compound NaOH. LOL doll. Probably seen advertisements for that. Maybe you have one. That's cool. I don't really want to have them in my house, but. And we have 0.5 liters, which is a volume. So 0.5 liters is a volume. You should know that for a volume equals 0.5 liters. Liters is volume. If you don't know 0.5 liters is a volume, you could open up the reference table again, go to page 1 of the reference table, and there's going to be like selected units there, all this information. And you can see, oh, moles is amount. Liters, oh, it is a volume. It's a quantity of a volume. And we have molarity there as well, which is solution concentration. So yeah, this chart, we should know most of this as well. We know mass, we know mass, length, pressure, temp. We went through joules with heat. Q equals mHV, Q equals mHF. We know time, minutes, all that time we know. We know atomic mass units, AMUs. This one, ppm, we'll go through next or later throughout the unit. So all that will be highlighted. We'll get there. All right, so now we got the point. We have the given information, and now we're trying to figure out what formula to use. It's Regents Day. You're trying to figure out what am I going to do. I'm hoping we have a Regents so you can express your knowledge for this class to a state test. I don't know if there's many teachers hoping you have a Regents, but I hope you have a Regents. I want you guys to have a chance to express what you know. Going through the year, it's happening. We're not teaching you. We're not learning. If you're doing what's expected, you're learning. So I want to give you, hopefully have the chance to perform on this Regents. All right, molarity you have moles, you have a compound, and you have a volume. So once you have that information listed, you should be able to look at the reference table and say, oh, which formula am I going to use? All right, molarity, there's molarity. I have liters, a volume. I have moles, number of moles. It's got to be that formula. We're looking for concentration. So molarity equals moles of solute over liters of solution. You can go through a checklist and say, where's the other formula I might have to use? Maybe you're stuck with this one. Maybe you say, hey, there's a molarity. Maybe it's that one. You have volume. We have looking for molarity, but you don't have a second set of data. This is going to come a little bit later throughout the year. So you have to use that first formula we highlighted, the one in our notes. So what I'm going to do here this time, instead of putting the formula right in this box to the right, I'm going to ask that you go all the way to the right, that's text box, grab it, condense it on down, make it smaller. There'll be a box for the given information. So again, all I did is just dragged it over to the left to make it smaller. Click inside the text box. If you have a Chromebook, put 2 fingers down on your keypad, or a laptop, works for my laptop. Or if you have a mouse, right-click your mouse, scroll on down, insert column to the right. Please click on insert column to the right, and then drag it on out. This is going to be where we're going to perform our work. So given information, organize. And then to the right, we're going to do the work. So the formula we need is going to be the one we already wrote down earlier in class. Molarity. Copy it, paste it on in. Molarity equals moles of solute over liters of solution. I'm going to color code this. Molarity, I'm going to leave pink. Moles, we'll leave that blue. And liters of solution is going to be the volume. Put that green. And I think you guys could figure this out now. You can figure out where to plug your information in. I color code it so you can see the connection. You don't have to color code it. So next up, I'm going to copy and paste this one more time below. I'm going to plug some information in there. So molarity is what you're looking for. I'm just going to call that M. Moles of solute, it's in blue. It's going to be 4.0 moles. Liters of solution is given to us in green, which is 0.50 liters. So that's the work you're going to be expressing here. 4 moles over 0.5 liters equals what? 4, so capital M, molarity. 4 divided by 0.5. 4 divided by 0.5. Throw in the calculator. Don't make a silly mistake. Thank you. Molarity equals 8. Yeah, 8. Say 8.0 if you wanted to. 8. The units are moles per liters. Moles divided by liters. You see that? Moles divided by liters. So there you go. There's the answer for the first example. The easiest type of question you may see on molarity, at least the mathematical easiest type of question. Does anybody have any concerns with that one? Doesn't get any easier than that one. Thanks, Alex. All right, next up, number 2. Alex, we're good? Example number 2, a little bit more difficult. How do I approach this? The exact same way that I did the last one. Figure out what you have, figure out what they're asking you to solve for, look at the reference table, find an approach. Let's go. Here we go. What is the molarity of a solution containing 82 grams of CaNO3 in 2 liters of solution? All right, I read it through once. Next time I'm going to take my pencil, I'm going to underline the important information or highlight the important information. What is the molarity? We're looking for molarity. Solution containing 82 grams. 82 grams. Looks like maybe a mass. 82 grams. The compound is CaNO3. Maybe we need that. So pull out as much information you can from the passage. And 2 liters of a solution. So all that stuff I got from the question. Now I'm going to find the given information and highlight it. Given info. First piece of data, I just go through the sentence again. I have molarity. We're looking for molarity again. Capital M represents molarity. It's molar. So I look for molarity. Next piece of information, we have 82 G's. 82 grams. Grams we should know is of mass. Lowercase m is mass. The compound we have is CaNO3. And the last thing we have is 2 liters. Copy this 2 liters in, paste it on in. 2 liters, think about it for a second. Liters, milliliters in a graduated cylinder is going to be a volume. So that's the information we have from the question. Okay, once you have that, I'm going to ask that you condense that text box. Bring it on over all the way to the left. Just organize that information there. And then I'm going to ask that you insert another cell to the right, or a column to the right. So again, 2 fingers down, insert column to the right. As we go throughout this year, you should become a better typer. You should be better at this, or more proficient with using Google Docs. I know I'm getting better. The more you use it, the better you're going to be. It's a good skill to have too. Typing, really good skill to have. I'm happy you guys actually have this ability. Because people in the past, typing a paper in chemistry class or typing a paper in whatever, using a computer in the past, students, I have noticed, have not done it very well. Hopefully you're getting better at it. All right, so I had another cell over here to the right, and now I'm going to look at the reference table and say, hey, what am I going to do? So I have this information. This is a Regents question, and I don't have the notes used because the Regents, they're not going to let me use my notes. We have molarity, mass, a compound, and volume. So go through that process. We're looking for molarity. Find molarity. Okay, there's molarity there. The only other time you see molarity is here. So it's got to be one of these formulas. Let's see. What else do we have? Moles of solute. Do I have moles of solute over here? No, you don't have moles of solute. I have mass. I have a compound. And I have a volume. But I do have volume. Okay. Volume, good. But I don't have moles. Oh, no. Maybe it's not that formula. You're saying, oh, maybe I have to use a different formula. Molarity of volume. Oh, molarity of volume. That works out. But I don't have another set of molarity and volumes. I don't have another set of data for those. So both of these formulas have two variables. You're going to have to find one of these variables. You're going to solve for one of them. The one you're going to have to solve for in this situation is going to be the moles. So you're going to have to solve for this one right here. Moles, right here. Moles of solute. You have to solve for it. How? Use that reference table. Moles. Find moles. Oh, moles. Flashback from the past. Moles. Moles is given mass over GFM. Oh, I got it. I got you, Mr. Brown. You're saying given mass, GFM could come from that compound. So what we're going to do, we're going to solve for the number of moles. We'll find moles down here. We'll eventually solve for that. Once we solve that value, we'll plug it into there. And then we have the volume as well. So it's like a two-step, maybe three-step problem to get to here. So hopefully you could figure out the approach to get to molarity. It's got to be that formula. You have that. You don't have moles. So to figure out the number of moles, you're plugging it into that formula. But first you have to solve for that, GFM. All right, so let's do this. All right, so go back to the drawing board. Here's our page notes. We figured out an approach. This is the most difficult type of question you may see on this topic. All right, so the first thing is I'm going to put the molarity formula. I'm going to copy that molarity formula. Copy. And before I do that, I'm going to call this step number one. Step one. Paste that in. Stretch this on out. You make the font smaller. Molarity. So molarity equals moles of solute, which we don't have, over liters of solution. So I'm going to put moles. I need moles over here. Got to solve for moles. I'm going to copy that formula down again. I'm going to paste it below. I'm going to abbreviate this a little bit. Molarity is going to be capital M. Moles of solute we have to solve for. So we're going to solve for moles. But we do have a volume. Volume's 2.0 liters. So now you get stuck. You're going through this process. Okay, can't have two variables. You got to solve for one of them. And now you know you have to use the mole formula. number of moles. So this is where you hit like a point where you use a reference table. I have to find moles. So again, I'm going to ask that you add another cell to the right, add a column to the right. Step number 2, we have to solve for number of moles. Step 2, solve for moles. The formula for moles on the reference table, you're going to see number of moles, hashtag moles, equals given mass, oops, over the GFM. Given mass over the gram formula mass. And we did a lot of examples like this last time. GFM, gram formula mass. Of course, I will color code this. So number of moles equals given mass over GFM. Number of moles I'm going to keep as blue. We'll solve for that. The given mass is yellow. It's in the passage, the question. And the GFM is going to have to come from a compound, CaNO3 All this for 1 point on the Regents. It might be a short answer question. You might ask for a couple of steps. So it might be more than 1 point. All right, so moles equals given mass over GFM. So here we go. I'm going to copy that formula down again. Copy. I'm going to paste it below. Number of moles is what you're looking for. The given mass is 82.0 grams. And now you're stuck. You're like, oh no, I have to do GFMs. Yeah. Gotta do GFM with CaNO3 too. So we're gonna have to do that as well. So step 1, step 2. If you're stuck, you don't know what's going on, please let me know. So next thing I'm gonna do, I'm gonna add another cell to the right, another column to the right. Right click your mouse, 2 fingers down, insert column to the right, one more cell here. Make my text a little bit smaller just so it's on the same line. And we're going to solve for the GFM. So now we're going to solve for the GFM of this compound. So I want to solve the GFM. So step 3, solve the GFM. Step 3, solve for the GFM of that compound. How do you do GFMs again? Gram formula mass. What's going to happen? It's going to be the ion. It's going to be number of atoms, number of moles times the mass. Then you add them all together. So a compound is CaNO3 2. How many CAs are present? Anybody? How many moles of Ca are present? It's a good question. How many CAs are present? How many atoms of Ca are there? It's a rough crowd today. Maybe I'm going too fast. There's one CA. Thank you. There's one CA. Thank you, guys. Now they're rolling in. Maybe you need to cut some time to catch up. There's one CA. The mass is going to be on the reference table. So the mass comes from the periodic table. Let's find that for Ca. There's Ca. Mass of Ca, if I look at the hundreds place, if that number is greater than 5, it rounds it on up before. So tens place. So 40.1 is the mass of Ca. 40.1 times 1 is 40.1 grams per mole, or you can say AMU. How many nitrogens are present there? Thanks, crisscross. Nitrogens, so what's going to happen, that 2 is going to be transferred to everything inside the parentheses. So that 2 is transferred to the O, transferred to the N. So there's 2 moles of nitrogen. 2. Mass of nitrogen comes from the reference table again. Find nitrogen on the reference table. There it is. Mass of nitrogen is going to be 14.0. 14.0. Yes. 14.0. 14.0 times 2 is 28.0. So yeah, this is a good review. And last is, how many O's are there? O's. Yeah, 2 times 3. There's going to be 6 moles. Who's that? 6 moles of oxygen. My kids love learning chemistry. The mass of oxygen is right there. So 16.0 is going to be mass of oxygen. You probably memorized that one. You've seen that one quite a bit. 16.0. 16 times 6, 96. That's going to be grams per mole. Last step is you have to add them all together, and that's going to be the total GFM. Please let me know what the GFM is for CaNO32. Please throw in the chat when you derive an answer. Okay, I'm 2 for 2, 2 answers here. They both have the same answer. It matches with mine as well. The GFM of the compound is 164.1. What grams per mole? So yeah, this is still the same question, folks. We're almost done though. That's the GFM for CaNO32. Next up, take that GFM that you have, you just calculated, plug it into your GFM for number of moles. So I plugged it into that. Let's plug it in. Take out that GFM. Now we'll put 164.1 grams per mole. How many moles do we have? How many moles are we represented now? how many moles are present. So divide both values out. How many moles are present? Yeah, so A2 divided by 164.1 is going to be 0.5 units moles. How'd you get moles? You canceled out grams. Grams cancels out. What's left over is just moles. So 0.5 moles is unit. Good. So I'll put 0.5 moles, whatever. And that 0.5 moles, now moles are going to be added to the beginning of step number 1. So you're going to take that. So what just happened? I took this and plugged it into there. I'm going to take this moles and plug it into there. So plug it on in. Getting pretty darn close. So now we have 0.5 moles. 0.5 moles. And we could solve for molarity. After all that, a lot of stuff we had to do. Now we could solve for the molarity of the solution. So 0.5 divided by 2 gives us a molarity of so molar or molarity of the solution is equal to what? So our last step is divide 0.5 by 2. 0.5 divided by 2 equals thank you. 0.5 divided by 2 equals 0.25. The units could be moles per liters. Or the units could be 0.25 molarity. So either one of those units would be acceptable for this problem. Yeah, long problem there. Took some time to get that problem solved. If you followed the flow, you understood the flow, you're in fantastic shape for this topic. Maybe you want to rewatch this video after I post it up here. Maybe it's too much time to color code. You couldn't really comprehend too much. Maybe you want to try to do this problem again on your own. You could check your work right there. Yeah, you could say 0.25 or you could say 0.3 would round up as well. For molarity solutions, I would leave it to the hundreds place, so I probably would go that first answer instead. All right, guys, that's it for notes. Notes are done. Any questions on what just happened there? A lot of stuff. But what just happened? That question, why, what, how'd you do that? You plug in your moles. You found moles now. Maybe you want to plug in your GFM. So you're given information. Looks a lot more complete now. Leave it organized. Makes it easier for you at the end. Questions? All right, guys, that's it for the note packet. You can close that out once you're done. I'm going to play a video. If you need to copy your notes down a little longer, feel free to. But now I'm going to play a video on concentration and molarity. Okay, someone said they can't hear it. Make sure it's, thank you.
Is used in calculations along with some definitions. I guess the animals are getting out of hand today. So what is concentration? Well, first we need some.
Sorry. Guess we'll start again.
Welcome to Molarity, in which we will explore what concentration is, how molarity is expressed, and how molarity is used in calculations along with some definitions. I guess the animals are getting out of hand today. So what is concentration? Well, first we need some water, but let's get a second glass to dissolve something into and define concentration as how much substance is dissolved in a given solvent. Dissolving a substance in water creates a solution. If we dissolve even more substance, then we get a solution with a higher concentration, and by comparison, the other solution has a lower concentration. Before we go further, let's define some of the components of our illustration. First, there is the solvent, the substance that dissolves the solute. And for our purposes, the solvent is water, which is the most common solvent. Solute is the substance that gets dissolved, and solution is the mixture of the solvent and the solute. The more solute there is per amount of solvent, the more concentrated the solution gets. Molarity is one way of expressing concentration. How is molarity expressed? Molarity is a measure of concentration. Molarity is the number of moles of solute divided by liters of solution, expressed as moles per liter, and symbolized with a capital M, sometimes italicized, which is pronounced molar. Molar. Let's say we have a 1.25 molar solution of KCl, potassium chloride. So 1.25 is our molarity. 1.25 molar KCl tells us there are 1.25 moles of KCl dissolved for every 1 liter of solution, or 1.25 moles per liter. 1.25 molar represents 1.25 moles per liter. Let's take a look at how we can use molarity mathematically. First, we will look at how molarity is calculated, and then use molarity in a calculation. First problem, what is the molarity of 0.65 moles of sodium fluoride dissolved in a total volume of 0.50 liters? Molarity is moles per liter, so we divide 0.65 moles by 0.50 liters of solution, and find the concentration to be 1.3 moles per liter, or 1.3 molar sodium fluoride. The molarity is 1.3 molar. Problem number 2, in which we now have not moles but grams. What is the molarity of 25.2 grams of sodium fluoride dissolved in a total volume of 0.75 liters? Since we have grams and not moles, the first step would be to determine the number of moles using the molar mass of sodium fluoride, which is 42.0 grams per mole. Here, grams cancel, and now we have 0.60 moles sodium fluoride. Molarity is moles per liter, so 0.60 moles divided by 0.75 liters gives us 0.8 molar sodium fluoride. Now, 2 problems to look at using molarity in a.
Okay, guys, I'm going to stop that video there. There's going to go through more examples, but I'm going to do more examples next time in class as well. So here we go. We're done molarity for now. We're going to analyze the examples next time in class. We'll go through some of the exit pass questions, or I might give you time in class to work on the exit pass on molarity too. So again, that is going to be extended for next week, not due tomorrow. Your examples here, good thing no one did them because I would have guessed you might have cheated, but we will do these examples next time. On that note, folks, that's it for today. Have a good day. Have a good weekend. Make good decisions. Go for a walk outside. I definitely will be after school ends today as well. See you later. Stay safe.
Have a good day.
Thanks. Go Bucks. Bye, guys. Have a good one. Bye, John. Bye, Kai. Bye, Nadina. Have a good one. Asim, good luck with that hand. Bye, Nadina.